Hi guys, welcome back to my channel. In this video, I'll be taking you through critical values. Now, critical values or somebody say critical points. You can also see critical points. So a critical point or critical value in calculus is a special point in the function. What does this point do or what makes it so unique? Now, if I draw a graph of my x against my y and I have a function, so I'll have a function, right? Now, you observe that our function will at a point increase. Let me make it bigger. So, drawing my Cartesian bigger like this, having a function somehow like this. So, you realize that our function is starting from this point. It will move and move and move and move. And at a certain point, it will rest and change direction. So, there are special points within our function where there is a change of direction. There is a change of the gradient, right? So it moved, and upon reaching this critical point, it turned changed its direction. And also here at this critical point, it will rest. Then after it will start moving up in that order. So using this graph, critical point should be very, very, very clear to you. Now, a critical point in a function is is a particular value c or a particular number c. So the critical point is actually the values on the x axis, okay? Values on the x axis that will give rise to this resting faces, okay? This resting faces. So our f of x is the main function, but the critical values we represent as c, okay? So meaning that there is going to be a c, f of c, right? F of c. So now we have two main conditions for critical values. A point C is said to be a critical value when f prime of C gives me 0. So if I differentiate my function and I put the C inside, I should get 0. What does this mean? Now, whenever you are finding the derivative of a function, it gives you what we call the gradient function or the gradient. And I told you that at the critical point, there is nothing like movement. It's a resting phase. So there is no movement. So meaning that the change of the variables there will be 0. So for us to get a critical value c, when I put c into my gradient function, I should get 0. Tell me that there is no change in direction. Also, if I put f prime of c, if I put my c into the derivative, I should also get a situation where my gradient will not exist. So it's either my gradient doesn't exist at all or it will be 0. Okay. So these are the two conditions for us to get our critical value. Let's take a couple of problems to see how it is. So find a critical point. Find the critical point of, so I have my first one to be f of x is equal to 10x squared plus 4x. Then the second one is f of x is equal to 6x to the power 5 plus 33x to the power 4 minus 30x to the power 3 plus 100. So let's solve it. We want a critical point of these two functions. So let's take the first one. F of x is equal to 10x squared plus 4x. To find a critical point, as I said, you only find f prime of what? C should give you 0, where C is the point you're looking out for. So without using C, we can put x or anything. But the goal is to differentiate the function you have here. So what do? Our f prime of x simply will be equal to what? 20x plus 4. You can clearly see it from here. So once you get 20x plus 4, we are going to equate this to 0, and you have, so you put c, right? So f prime of c is equal to 20c plus 4, and it should be equal to 0. So I'm going to get 20c to be equal to negative 4 My C is simply equal to negative 4 over 20, giving me negative 1 over 5. So my critical point is negative 1 on 5. Now let's solve for our second part of the question. So the second function, which is f of x is equal to 6x to the power 5 plus 33x to the power 4 minus 30x to the power 3 plus 100. You want to find a critical point. All that you do is you find f prime of x first. What is that? So if I differentiate each here, I'm going to get 30x to the power 4 plus now 4 times 33. What is 4 times 33? That is 132x cubed. Then here it will give you minus 90x squared. Then here will be 0, right? So at this point, we are supposed to equate this to 0. But first of all, let's convert everything to c so that I get our critical point. So f prime of c will simply be equal to 30 c to the power 4 plus 152 c to the power 3 minus 90 c squared is equal to 0. What are the values of c? And that will give us our critical points. So to solve for the values of c, we can do some further simplifications here. I can take x squared out, but I can also factorize 6. So I can have 6c squared, open brackets, here will be 5c squared plus no minus 3. So you know that when I factorize 6c squared, here will give me a number, right? This will give me a number. So 36 to the power 4. If I factorize 6c squared, I'm going to have 5c squared. Because when I multiply, I'll get this again. Here will give me plus what? 6 times what will give us 6? 6 times 22 c, right? Because this cubic, so this will only take two of the three and it's left with one. Minus, realize that 6 goes into 90 how many times? 6 goes into 90 15 times. So 15 is equal to 0. So once I have this, I'll get my first value as 6c squared to be equal to 0, c will be equal to 0. Then I'll handle the other part of it. So the other part of it would be what I have here. 5c squared plus 22c minus 15 will also be equal to 0. And that will give me 5x minus 3 multiplying x plus 5 should be equal to 0. I'll have x to be equal to 3 out of 5, then x to be equal to negative 5. So my critical point C will be 0, 3 out of 5, then negative 5. And that brings me to the end of critical values or critical points. Thank you for watching this video. Don't forget to subscribe, like, and share. See you in the next section on maxima and minima.